S. Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
Welcome to S. Chand Academy, and I am Anmol Bhatia. In this part of video, we will be learning about the concept which is kinetics of rigid body through the help of certain problems. The problems that we have done in the previous videos were related to the motion of the particle, in which one equation was given to you and you have to derive that equation so as to find out the velocity and acceleration. But in this particular set of problems, you have to use certain equations of motions, and they have a particular connection with the rigid bodies. So, we will straight away come to those numerical problems.
If you want to study this topic in detail, refer to the book by S. Chan Publishing. Link is provided in the description box.
The topic is problems which are based on kinetics of the rigid body, and I am coming to the problem straight away. This problem states that there is a car and the driver of the car is driving the car at 90 km/h. Now, the driver observes red light which is 200 meter ahead. The red light is 200 meter ahead of him, and that light turns red. The traffic light is timed to remain red for 15 seconds. So, this is a particular case in which the traffic light remains red for 15 seconds. Now, the driver wishes to pass the light without stopping. Find the required minimum acceleration that the driver needs to provide. So, this is one of the general application of the concept that you are studying. Let us say you are going on a road and you have observed that the traffic light is turning red, and you know that it remains red for 15 seconds, and you do not want to stop at the red light. Without stopping, you need to pass by the red light. So, what would be the minimum acceleration that would be required so that the vehicle do not stop? So, we can use this concept of the rigid body which is there in case of in particular motion. So, here it is given to us that the speed of the car is 90. So, you are given with the speed of the car as 90, and the distance it is observed that the red light is 200 meter ahead that light, and time is also mentioned to us, which is 15 seconds. What we need to find out? We need to find out the acceleration of this. So, first and foremost, what you have to do, you have to convert the speed of the car, which is 90 km/h, into meter per seconds. So, this velocity or the speed of the car is to be converted. So, 90 kilometers. So, kilometers is to be multiplied by 1000 to be converted into meters, and hours are to be multiplied by 1 hour is converted into second by multiplying it with 3600. So, velocity comes out to be 25 meter per second from this particular set. Now, additionally, using the equation of the motion, we can find out the acceleration part. So, it is mentioned that the traffic light is 200 meter ahead of the driver. So, in place of S, you have to substitute 200. The equation that we are using is the second equation of motion, which is S equals to ut plus half at square. We have used that equation particularly. So, u here is having a value which is 25 that we have just calculated from this first part. So, the value of u is to be substituted here, and the time's value is how much? 15 seconds. So, 15 seconds is to be substituted here, plus half times a into time remains the same value, 15 seconds square. 15 seconds is that particular time in which the traffic light remains red. So, we have substituted 15 here, After solving, we will get this value as minus 1.56 meter per second square. That means the driver needs to deaccelerate by 1.56 meter per second. So, acceleration that he needs to maintain is by stopping that vehicle. So, by reducing the velocity of that vehicle. So, initial velocity of the vehicle was mentioned to be 25. So, if we deaccelerate that vehicle, so after deaccelerating he would observe that when he passed by that traffic light, the signal would be green. That means without stopping the vehicle he would pass by. But how can we justify or how can we check that the car was in motion or the car was at rest? So, for that also we can use the equation of motion, and that equation of motion will be v equals to u plus at. So, final velocity of the vehicle, if it comes out to be 0, that means the vehicle was at rest in the traffic light. So, we need to find out v. Initial velocity is u given to us. So, here you can substitute the value of u as 25 from that particular equation. Acceleration is minus 1.56 and time is 15. So, substitute the value, you will get v's value as 1.5 meter per second. Value of v comes out to be 1.6 meter per second. That means the body or the car was not at rest, the car was in motion. So, initial velocity was 25 and after coming to that particular traffic light, so the velocity is 1.6 meter per second. That means the vehicle is still in motion. So, this is the answer to that particular question. Now, we will look at the concept again with the help of another numerical. So, in this particular set of numericals, you have to use one particular equation of distance, and the distance that is required to be covered in nth seconds. So, that equation would be coming into the picture with the help of this particular numerical. So, what the numerical says, it says that a body is moving with a uniform acceleration and it covers 15 meters in 5th seconds. So, in 5th second the body covers 15 meters and in 10th second the body covers 25 meters. There are two cases of the time period and the distance value. Now, what is required? You need to find out the initial velocity of the body and acceleration of the body. So, two concepts, velocity is required and acceleration of the body is required. So, how can we solve this? So, initial velocity is required, which is u is required, and acceleration is required. And for this we have to use this particular formula, which is Sn, that is equal to Sn minus 1. This is particularly for the distance which is being covered, and the Snth value in place of any particular time period, that would be u plus a by 2 into 2n minus 1. This is the formula for the Snth second. So, if a body covers this distance in nth second, you have to use this formula for that particular case. Now, what is mentioned? It is mentioned that for the 5th second. So, for the 5th second means you need to put n as 5. So, it comes out to be u plus a by 2 into, in place of n you have to substitute 5 minus 1. So, here the first case would be S5. So, it would be u plus a by 2 into, in place of n you have to substitute 5 minus 1. This comes out to be 15 equals to u plus 9a by 2. This would be your first equation, particularly in terms of u and a. Now, we have to go for the finding out another equation. That equation would be in terms of u and a again, and the input that is to be used is distance covered in 10 seconds part. So, here for the 10th second you need to find out the distance value. So for S10 you have to use this particular formula, which is u plus a by 2, 2 into 10 minus 1. So 2n minus 1 was the formula. So S10 it would be for 25, the value is 25, and u plus a by 2 into, on solving this comes out to be 19a by 2. This is your second equation. Now I need to solve those two equations, because I have two equations and I have two unknowns. So I need to solve them by substituting the values, or by subtracting the same, so that a comes out from the equation. So I have subtracted both of those values, which is 25 minus 15. U plus 19a by 2 was the value of the second equation, and the first equation was u plus 9a by 2. So when I subtract both of them, I will get what, 25 minus 15, which is 10, and u and u gets cancelled out. So it becomes 0. 19a by 2 and 9a by 2 comes out to be 10a by 2. So as you can see that 10 equals to 10a by 2 is there. So you can cancel it out. So acceleration comes out to be 2 meter per second square. So this is the case in which acceleration is coming out to be 2 meter per second square from this particular set. Now acceleration is there with us. Now what you need to find out, you are also required to find out the initial velocity. So you know that you have got the particular equation of the distance part, which is 15 equals to u plus 9a by 2, or maybe the second equation also, that was also in terms of u and a. So what you have got? You have got this acceleration from both the equations. So you can substitute this value of acceleration in any of the equation. So in any of the equation you have substituted acceleration as 2. So it comes out to be 15 equals to u plus 9 into, in place of acceleration you have to substitute 2. So 2 and 2 gets cancelled out. So on solving you will get the value of initial velocity, which is 6 meter per second. So this is the case in which you have got the initial velocity and you have got the acceleration. So here you have used a particular formula for the distance, and that particular formula I have told you. So on summarizing this particular question, you have used a formula which is Sn. Sn equals to that particular formula, and that is mentioned that for 5th second you have the value of distance as this, and for the 10th second you have the value of distance as this. So on substituting both these values, you can basically get two equations and you will get two unknowns. On subtracting both of them, you can find out acceleration, and once you obtain the value of acceleration, you have to substitute that value in terms of any of the two equations, so that this initial value of this initial velocity comes into picture. So that is what was required in the question. So we stop here for a short break. After coming back from the break, we will learn the same concept with the help of more examples.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy after the break. Before going to the break, we have learned the concept of kinetics of the rigid body with the help of certain examples. So we will dig more into this concept with the help of certain more examples. So let us look at the problem. So the next problem here is related to a concept in which you have to use the equations of motion, and additionally you have to use the concept of integration in this particular example. So the problem says that there is a particle that moves along a straight line. So the particle is moving along a straight line, and that is having this particular set of equation, which is acceleration equals to minus 8 s raised to the power minus 2. So it is mentioned that a here is in meter per second square. That means A is the acceleration and S is in meters. So, that indicates distance, distance is in meters, and we are given one particular set of input value. And what is that input value mentioned? It is mentioned when the time is 15 seconds, distance is 4 meter and the velocity is 2 meter per second. So, this is one case that might be required in solving the problem. And what is required? Determine the acceleration when time is 2 seconds. This is what is desired. So, we need to find out the acceleration when the time is 2 seconds. So, we have a particle motion, and that particle motion is described as acceleration value in terms of distance, and one set is mentioned and you need to find out the acceleration when time is 2 seconds. So, when time is 2 seconds, we cannot substitute time as 2 seconds in this particular equation. So, we have to apply our brain so that it comes out to be so that this acceleration equation can be framed in terms of time. So, how can it be done? So, herein firstly we have to write this particular set in terms of symbolic expressions. So, as far as the question is concerned, acceleration is mentioned to us, which is minus 8 s raised to the power minus 2, and you are given with the value of time, which is 15 seconds, the value of s, which is 4, and the velocity value, which is 2 meter per second. What is required? It is required that acceleration when time is 2 seconds. So, acceleration is required when the time period is 2 seconds. So, what is the value of acceleration you have? Acceleration is basically dv by dt, but we do not have v and we cannot derivate this v in terms of t because the equation is mentioned in terms of s. So, what we have to do? We need to multiply and divide this particular equation with ds, and we need to club this ds by dt part. So, that ds by dt part is taken outside and this would be s. So, dv by ds may remain. So, ds by dt is velocity. So, velocity dv by ds. So, we will get this particular part, which is v dv by ds in terms of acceleration. Now, we have the value of acceleration as minus 8 s raised to the power minus 2, that would be equal to v dv by ds. Now, we need to obtain an equation. So, in order to obtain the equation, we need to multiply this ds part on the left hand side. So, this comes out to be minus 8 s raised to the power minus 2 ds is equal to v dv. Now, what we need to do? We need to integrate on both the sides. We have this equation, we have to integrate on both the sides so that one particular equation comes in. So, that the value of v dv is v square by 2. So, this is the case, v square by 2 and 8 s raised to the power minus 2. S raised to the power minus 2 we have to integrate. So, s raised to the power minus 2 plus 1 over minus 2 plus 1 would come out. So, 8 over s and plus 1 constant is there. So, you have got this equation number 1. Now, you are given with certain initial set which is indicating that time is 15 seconds, s is 4 meter and v is 2 meter. So, we have v and s. So, v and s can be substituted here so that the value of C1 comes out. So, the value of v is, what is the value? 2 and the value of s is 4. So, on substituting, what do we get? S is 2. So, 2 square is 4, 4 by 2 is 2 and this is 8 by 4 which is also 2. So, 2 minus 2 it comes out to be, C1 comes out to be 0. So, on substituting as C1 as 0, I will get the equation of V in terms of S as V equals to 4 upon root S. You can check that particular set by substituting the value of C as 0. So, V square by 2, that is equal to 8 by S, and C1 is 0. So V square equals to 8 into 2 is 16 over S. So when we remove this root, V comes out to be 4 over root S. This is V, this is V. But till now the question is not solved because we need to find out the acceleration when the time is 2 seconds. Till now we have not calculated the acceleration part. So how can we solve it? Furthermore, V equals to 4 by root S, that is mentioned. So we know that velocity is described in terms of this distance. So V equals to ds by dt. So in place of V we have substituted ds by dt, that would be 4 by root S. Now we need to rearrange the terms, root S into ds, that would be 4 into dt. Again we need to integrate it with respect to S and on that side with respect to t. So on integrating S raised to the power half ds, that comes out to be S raised to the power 3 by 2 over 3 by 2. So that would be replaced to 2 by 3 S raised to the power 3 by 2. And then 4 dt, integral of dt is t, 4t plus c2. This would be our second equation. Now as per the particular representation, we have the value of time as 15 seconds and we have the value of distance as 4. So distance and times equation it is. So the value of time is 15 seconds and the value of S is 4 meter. So on substituting we will get the value of C, and on solving we will get this value, which is this one, 2 by 3 S raised to the power 3 by 2, that is equal to 4t plus 4 by 3. Now we got one equation. Now you know that acceleration is there in terms of S and we got S in terms of t. So what can be done? We can substitute time as 2 seconds. So substitute time as 2 seconds here. So time can be substituted as 2 seconds. So 2 by 3 S raised to the power 3 by 2 equals to 4 into 2 plus 4 by 3. So on solving, S comes out to be 5.81. The value of S is 5.81 on substituting this time period as 2 seconds. So this S can be substituted in this particular equation, which is A equals to minus 8 S raised to the power minus 2. So minus 8 into, in place of S you have to write 5.81 raised to the power 2. So acceleration comes out to be minus 0.2373. So this solves this particular question. So on summarizing this particular question, you are given with acceleration in terms of distance, and what you are required to find out the acceleration when the time is 2 seconds. So what was the main idea? Idea was to get an equation of S in terms of t. That's what we obtained. So how can we obtain this? Initially we have written acceleration as v into dv by ds, and then on rearranging the terms we have integrated it. On integrating we obtained v in terms of s, and then those equations can be used to find out C1, those constants, and then finally the second set of equation by substituting v as ds by dt, so that s comes out in terms of t. So we can substitute this value of t as 2 seconds in this particular equation, so that s comes into the picture, and then that value of s can be substituted so that acceleration can be determined. Now another problem with the help of using the same concept. So it is mentioned that a stone thrown up vertically from the foot of the tower. So there is a tower in which I have thrown a stone from that foot of the tower. The height of the tower is 22 meter and the velocity is 12 meter per second. The stone is thrown upward with the help of this velocity and the height of the tower is 22. Simultaneously, it is mentioned that at the same time another stone is dropped from the top of the tower. So another stone is dropped from the top of the tower, and you need to find out the height at which the two stones cross each other. This is required, and this is one of the critical question, important question from the exam point of view. So, diagrammatically we will see first what is there in the question. So, it is mentioned that there is a tower which is of height 22 meters, and there is one point which is A point. From this A point I have thrown a stone vertically upward with a velocity of 12 meter per second as stated in the question. And at the same time, from the top of the same tower, which is, let us say, the point B, another stone is dropped. So, another stone is dropped, but it has an initial velocity of 0 because we are dropping that particular stone. Due to gravity, it would go beyond. So, what is required? You need to find out a particular height at which both the stones crosses each other. So, this height is required. If this is h, this total is 22, so this part comes out to be 22 minus h. How can we solve this question? So, we have to use the relation between h and this u. So, h equals to ut plus half gt square. The same equation, s equal to ut plus half at square. So, in place of s I have replaced h, and in place of acceleration I have used g. So, this is one of the case. Now, we have to write the equation. So, this equation I have told you that this is the major equation that we will be using, that would be h equals to ut plus half gt square, that would be your equation number A. So, for stone A, it is mentioned that we have thrown it vertically upward with the value of initial velocity 12 meter per second. So, in place of u, you have to write 12 in t, t remains t, half. In place of g, it is minus 9.8 because you are throwing it upward. So, minus 9.8, and the value of t is to be required, is to be found out. So, this is particularly your equation number 1. Now, for the stone B, you have to throw it from upwards. So, the height particularly would be 22 minus h. So, this height is to be considered 22 minus h, and initial velocity, as I have told you, is 0 for the B case. So, 0 into t plus half into, in place of g you have to write 9.8 which is positive, and t square. So, you got two equations, and you have to solve those two equations so that h can be determined or t can be determined. So, how can it be solved? So, in order to determine t, we have to remove this h. So, that can be done by adding those two equations. So, h and 22 minus h can be added up, so that it comes out to be, h and h cancels out, it comes out to be 22 equals to 12 into t. So, on solving, t comes out to be 11 by 6, 22 by 12, that comes out to be 11 by 6. And you have to find out the height at which the two stones cross each other. So, in place of the equation, which is this equation, h equals to ut plus half gt square, you have to substitute this time as 11 by 6. So, u is 12 into time is this 11 by 6 minus 9.8 into 9.8 by 2, which is half into g multiplied by t square. So, same the first equation, you have to substitute it. So, h comes out to be 5.513. So, 5.513 is that particular height in which the two stones would cross each other. So, this is a requirement or a mandatory question which is related to the same concept. So, what is there? What was there in the question? So, you have thrown one stone upward and one stone from the top of the tower, and you need to find out the particular height at which both the stones would cross each other. So, here you have to use that concept, that particular formula, which is h equals to ut plus half gt square, and from there you have two equations, which is this first equation considering the initial velocity and the second equation considering initial velocity as 0. So, that h can come out. So, the value of h after putting in this particular equation would come out to be 5.513. So, with this we come to the end of the video in which we learnt about the concept of kinetics of rigid body with the help of certain numerical problems. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.